So today we'll discuss about arrays. Okay, what are these arrays are there? So vectors we already completed. No? Okay, vectors we already completed. We'll see about the arrays. Arrays. What are these arrays? Okay. So suppose if you consider a vector, in vector we declare the size before the variable or after the variable.
Before the variable.
Declare the size before the variable. Okay, before the variable. Okay, and next, so that means vector. If you see the vector example, if you see, you will consider range 1 down to 0 a. Okay, this is vector. No, arrays is nothing but we will declare the variable outside after the variable. We need to declare the variable size after the variable. So range a 1 down to 0. This is nothing but array. Okay, so syntax is you have data type, variable, and size. Did you understood the difference between vectors and arrays? Hello. Yes.
I'm audible, sir. Yes, sir.
Yeah. So suppose vectors are there. So vector means suppose if you consider range 2 down to 0 a. Okay. A I am giving 3 tick binary 0 1 1. Okay. How it will store? It will store like horizontally, like this is the index 0 1 2, and so 0 1 1 will be stored. Okay,
Hmm.
and coming to the arrays reg a 2 down to 0. Okay, reg a 2 down to 0. So here I am allocating, that is a equal to 3 tick binary 0 1 1 means uh, uh, so so here we can't give like this. Okay, we can't give like this. Okay, so that means three locations are there. Three locations will form like this. Vertically, three locations will form. So here, 0th location, one location, and second location. Like this, it will form. Okay. So array means what? Array is not a group of bits. Okay. Array is not a group of bits. You need to indicate separately. Okay. Group of bits. Okay. So here, this is not possible in array. Individually, you need to store. Did you understood?
No.
Okay. Suppose like example, I am considering range a 1 down to 0. So how many locations will form?
Two locations.
Two locations. Okay. I am using begin begin. A of 0 equal to 2 and a of 1 equal to 3.
All.
Okay. And end module. Okay. So here what happens? Two locations will be formed. So this is the 0th location. This is first location. So in 0th location, 2 will be stored, and in first location, 3 will be stored. Is it fine? Like this, we need to
Yes,
store.
sir.
Understood? Okay. Next, suppose module test, I am initializing the array reg a 2 down to 0, reg a 2 down to 0, initial begin a of 0 equal to I am giving 5. Okay, a of 1 equal to I am storing 9, and a of 2 I am storing 3. End and end module. Okay, so in the array, what will be stored? Tell me. Anyway, 3 locations will be formed, no?
From 0th to 1, no?
0th to 1 or 2.
Same 593, sir.
But reg is how many bit?
Edge is 1 bit.
1 bit only it will store, no? Hmm.
So it will store only the the LSB bit.
Yes, LSB bit will be stored. So it will be converted into binary. Whatever the LSB bit is
1,
there, this one will be stored. Okay. And 9 means what? 1001.
1, 0, 0, 1. 1 is stored.
This one will be stored. And next 2 means 010. So this 0 will be stored. Did you understand?
Yes, sir. But in the last example 2, 3 also the LSB bit only stored.
3 will be stored. 3 I gave, no?
2, 3.
2, 3 means here this will be converted into binary means it will be 011. This LSB bit 1 will be stored.
Yeah, only the LSB bits are storing.
LSB bits are stored. Okay. And suppose, is it fine? This example is fine.
Yes, sir. Yes, sir.
Okay. And next example 2 we'll see. Example 2. Module test. Module test. I am declaring vector as well as array. Reg 1 down to 0, A, and 1 down to 0. After that 1 down to 0. Okay. So what is this? When you declare the size before the variable, this becomes
It is vector.
vector. When you declare the vector after the variable, this is
Array.
array. This is array. Okay. So that means, so this how you can analyze. So there are two locations are there. Okay. There are two locations are there. So that is nothing but array. This is 0,
0
1,
or 1.
1, and each location have how many bits? Again vector.
2 bits.
2 bits, 2 bits. Okay. So that means we can store. So these are nothing but total two locations. Two locations. In each location, we can store how many bits?
2
2
bits.
bits. We can store 2 bits. Okay. So like this. Okay. And suppose like example 3, if you see, um, I'm creating the memory. How to create the memory? Reg 7 down to 0, memo 31 down to 0. So this is memory creation. So total how many locations are there?
Total, that is the total 32 locations.
This is array. Total 32 locations. Total how many? So locations are 32. Okay, locations are 32. And what is the width of each location?
8 bits it can store.
Width of each location. Width of each location is 8 bit. Okay, 8 bit. Like this, you can make the memory. Okay. So suppose I'm using like module test. Module test. I'm creating reg 7 down to 0, memo 1 down to 0. Okay. Initial begin. Mem of 0 equal to 8-tick binary 1000 and 000111. Okay. And mem of 1 equal to 8-tick H12. Okay. And end module. Now total how many locations are there?
2 locations, each of 8 bits.
Each of 8 bits. Yeah, 2 locations, each of 8 bits. In first location, this is 0th location. This is first location. In 0th location, what I am storing?
1 triple 0 0 triple 1.
1 triple 0 0 triple 1. In second location,
hexadecimal 12, like we have to convert it into binary.
0 0 0 1
Zero
and
one
0 0
zero zero one
1
zero.
0. Okay, like this we will store. Okay, yeah. So we got the point. Okay. Next, next important. So this is very important related to arrays. I'm writing module test, module test, reg, reg, 1 down to 0, memo 1 down to 0, and initial begin memo 0 equal to 2 tick binary 1 0, memo 1 equal to 2 tick binary 1 1, end and end module. So here what I am doing,
Two locations,
I am creating two
2 bits,
locations.
two bits storage.
Yeah. So 2 bits, two locations, each of 2 bits. Okay.
Bit.
Here I'm so this is 0th location and first location. Okay. This is
Yes.
nothing but what? So this is nothing but index. We call as index. Okay. This is nothing but index. So 10 and 11.
One one.
These are nothing but what we call contents. This is memory index, and this is nothing but contents. Okay. So that means this is index. Okay. Yeah. Is it fine? You understood? This is index and this is contents. Okay.
Yes, sir. Yes, sir.
Next, suppose. mm, mm, so in case of suppose uh, if I consider a vector, okay. Suppose if I consider vector reg 1 down to 0, I am considering as mem. Okay. Mem equal to 2 tick binary 0 1, mem equal to 2 tick binary 0 1, and mem of 0 equal to 1, mem of 1 equal to 0. Is vector slicing is possible in the vectors?
I guess yes, sir. Vector slicing is possible.
Vector slicing is possible. We can access each and 0th bit and first bit. Okay,
First
we
bit.
can access. Okay, but coming to arrays, suppose uh, I will consider reg 1 down to 0, mem of 1 down to 0. So that means how many locations are forming? Two locations, no?
Two locations, 2 bits. Huh.
2 bits. Two locations, 2 bits. This is 0th location, first location. So mem of 0 equal to 2 tick binary 0 1. Mem of 1 equal to 2 tick binary 1 0. Okay. This is 0 1 and 1 0. Okay. So can I access only this LSB bit related to vectors?
Related to vector, you can access, I guess, sir.
Will related to here. This is the combination of vectors and arrays. This is vector.
Mm-hmm.
This is nothing but arrays.
Array. You can access in vectors, I guess. You told in the previous.
Yeah, we can access in the vectors, but here arrays also came, no?
Hmm.
So here arrays also came. So can we access only this LSB bit? Can we access?
I don't know, sir. Maybe we
So
cannot access.
we cannot access. So if it is arrays are adding means in this case, in this case, vector slicing is not possible. Vector slicing is not possible. You can only access these 2 bits. You can't access 1 bit in this array. With respect to, it is a combination of what? A combination of like arrays and vectors. Is it fine?
Yes, sir. Understood.
Understood. Okay. So next we'll see the port rule connections. So port rule connections. Suppose next we'll see the. So we completed with all the data types. Any doubts are there?
No, sir.
Port rule connections. Okay. So port rule connections. If you take, suppose if you have full adder is there. Okay. So if you see the full adder, uh, full adder. One second. Yeah. So the port rule connections. Suppose if it is a full adder, how many inputs are there?
Three inputs.
Yeah, three inputs are there. So three inputs are there. So this is A, B, and Cn. And how many outputs? Sum and carry.
Carry.
Okay.
Two
Sum and
outputs.
carry. Sum and carry. Okay. So like suppose if you want to write on the top module. Okay. So there are some rules, port rule connections you need to follow. Okay. So port rule connections are suppose. So here this is my top module. Let us take this is my top module. Means what? When you are writing the test bench. Okay. When you are writing the test bench, this is my top module. Okay. So this is a top module means inside there will be a design. No, inside there will be a design. So for design, the inputs are what? Inputs are A, B, and C, and outputs are sum and
Some carry.
carry. Okay, sum and carry. Okay, so that means through the test bench you are giving some variables. Okay, A, B, C in, and here also it is coming through this one, and you are giving sum and carry. Okay, so you need to follow some port rule connections. So whatever the variables related to test bench, this should be what data type means, it should be reg or net data type. It should
Hmm.
be reg or net data type. And whatever the design inputs and outputs are there, this should be net data type. Okay, and this design outputs can be net data type or reg data type.
Okay.
Okay, and the outputs, that means outputs of the variables of the test bench should be net data type. Should be net data type. Did you understood the port rule connections?
Sir, understood.
Understood. So that means here, suppose if you are like if you are writing for AND gate,
Hmm.
if you are writing for AND gate, okay. So AND gate is nothing but this is my design. Okay, this is my design. AND gate is my design. Okay, AND gate is my design. For this AND gate, you have how many inputs? Two inputs, A, B, and what is the output?
Y.
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 Okay. So for this you are writing. So in order to verify this AND gate, you need to write the test bench. That is we'll discuss. So this is under the top module. Okay. So that means this test bench doesn't have the ports. So just this have the variables only. Okay. So what are the variables? A test bench variables are A underscore TB and B underscore TB, and again this is given to test bench Y underscore TB. Okay. So that means I told you test bench variables. This could be what data type? This should can be reg or
Reg or
net
wire.
data type.
Hmm.
Reg or Y data type. And design inputs are should be which data type?
Design
Net
inputs A and B should be net data
net
type,
data
means
type.
wire.
Y should be which data type? It should be net or reg data type. Okay. Again, test bench variables. This Y underscore TB should be which data type? It should be net data type.
Wire. Yeah, wire.
Net means by data type. Okay. So here, suppose if I want to instantiate the design, okay, there are two types of instantiation are there. Connection by
This
name
will
and
be, sir. This will be for the test bench.
test bench, or one more modeling is there, structural modeling. Structural modeling means here, suppose you are like what we call, you are designing the full adder by using half adder. No?
Hmm.
In digital, we already seen, no?
Yes, sir.
Okay. So that means you are designing. Okay. So on the top module, you are designing. So you are designing the half adder. On the top module, you are designing full adder, no?
Ah,
So that means input for the full adders are different. Input for the half adders are different. Output for the half
different.
adder
Yes.
also different. Output for the full adder also different. So here also you need to follow the port rule connection.
Portal.
Did you understand the concept? Okay. In structural
Yes.
modeling also you need to follow the port rule connection. Not only test bench. In the structural modeling also you need to follow the port rule connections. Is it fine? Shall I move forward?
Yes, sir.
Okay. So here you see, suppose connection by name is there, connection by name. So there are that means there are two types of instantiations are there. One is instantiation, instantiation. There are two types are there. One is connection by name, and next connection by position with order list. Connection by position with order list. Okay. So what is this instantiation? That means, example, this full adder you implemented by using what? Two half adders and one OR gate, no? In digital, we
Hmm.
already seen, no? So, what I will do means, I will write the code for half adder and I will instantiate how many times? Two times.
Two times.
And for OR gate, I will write for by using gate level modeling, for OR gate, I will write so that I can write the code for full adder, no?
Yes, sir.
Similarly, suppose ripple carry adder is there. How many full adders are required?
Two full ladders, I guess.
Four full adders are required.
Four full ladders. Hmm.
Four full adders. First, I will write the code for full adder. I will instantiate by how many times?
Four
Four times.
times.
Okay. Suppose if I write separately for all the full adders, each full adder take 10 lines of code means, so 10 fours are, it will take 40 lines of code. Okay. Suppose if you are using this instantiation, it will take some 10 to 12 lines of code. Okay. So which is
10 to
optimized
12.
code? Instantiation is optimized code, no?
Yes, sir.
Okay. So so for simple way I'm writing the code for AND gate, and next I'm writing for test bench. How to write the test bench separately I will give. First we'll discuss connection by name. Okay. So for the AND gate, how I write? So module and module name. What is the module name? And underscore gate,
And
and you need to declare the input. Input a comma b, and output.
output.
So remember, I'm using the behavioral modeling. If you are using behavioral modeling, output should be reg data type. Okay, reg data type. Always, this I will tell you. Don't worry. Behavioral modeling. Always at the rate. I need to use star. Star is nothing but implication operator. If there any input change in the input, then there is a change in the output. Okay. So begin y equal to what I am writing, a logical and of b, end and end module. What is this? This is my code. Okay, this is my code for simple AND gate. Okay, by using which modeling means behavioral modeling. Okay, by using which modeling? Behavioral modeling. Okay, if it is a connection by name, if I want to write the test bench, so how I can write a connection by name? Is this code you understood?
Yes, sir.
Okay, so if it is a connection by name, the syntax will be like this. Syntax will be design name, design name, and next instance name. Okay, and followed by what that is dot design input and test bench variables. Within the bracket you will get test bench variable dot design input test bench variables dot comma dot design output test bench variables, like this. Okay. So how I can write module TB module TB. I am declaring with which data type wire A underscore TB and B underscore TB and C underscore TB. Okay. And
Why
wire. I am declaring with wire data type. And what is
why
my
TB, sir?
wire?
Why
Which
TB, not CTB here?
wire and A underscore TB. Wire.
B, the output is Y, right? You're taking.
All are taking as wire only.
Why, sir, not C here? I mean, like,
What is your doubt you are asking? Tell me.
why you took in like A, B, C? It has to come Y, right?
Sorry,
Output.
sorry, sorry, sorry. Why no? Yeah. Okay. Y underscore TB. Okay. Next, what is my design name?
And gate.
And gate. Yeah. So and underscore gate and next instance name. Let us take my instance name is A1. My instance name is what? A1. Okay. Y equal to A and B. Okay. So instance name is what? A1. Okay. Dot A bracket A underscore TB comma dot B underscore TB comma dot Y underscore TB and end module. Like this you need to write. Did you understood the connection by name?
Yes, sir.
Hmm? So
Hmm.
next connection by position if you take. So connection by position means how to write means so here for the AND gate I am writing data flow modeling. Okay, that is, previously I wrote BRL modeling. Data flow modeling how you need to write means like you need to write this is connection by order with so this is order connection by order with connection by connection by position with order list. Connection by position with order list. Connection by position with order list. Okay, it's order list. So here you see. So I'm writing module and underscore gate and underscore gate. I'm declaring input A comma B. Okay, and output Y. So I'm not declaring any data type. It will take as which data type?
Wire data type.
Y data type. Yeah. I'll use a continuous assignment statement that is assign y equal to what? A and B. Y equal to what? A and B and end module. This is if you represent with expressions that is nothing but data flow modeling. Okay. So in data flow modeling, all the inputs and outputs should be wire data type.
Wire.
Okay. Okay. So next, I'm writing the test bench. So module top, module TB, or you can use the test bench as module top. So you need to declare with wire. The variables I am declaring with what x, y, z, x, y, z. Okay, and how I am declaring? So that means design name. What is my design name? And underscore gate
Gate.
and instance name. Let us take instance name is optional only. You can use DUT, UUT, RE1, anything you can take. Okay, design under
Design
test.
and
This
test.
is design under test. How you declare the inputs? Same like that you need to declare x, y, z. Like this you need to declare and end module.
By position. Okay.
This is the connection by position with order list. Is it fine?
Yes, sir.
Okay. Suppose uh, so like full adder using half adder is there. Okay, full adder using half adder is there. So this I am writing with connection by position with order list. Okay, sorry, connection by name. First connection by name I am writing, and next connection by position I am writing. Okay, port rule connection. So full adder full adder using half adder. Okay, full adder using half adder. Okay, so you have one half adder. Okay, one more half adder. Okay, so half adder inputs are what? A and B, S and C. Okay, and this is half adder one. And next here A, B, and S, C. Okay, this is half adder two. Okay, so and sum is given to this input. Okay, and these uh, these outputs are given outside. So this is nothing but what? A underscore FA and B underscore FA. Okay, and one more input is there. This is carry underscore FA. Okay, C in underscore FA, carry in underscore FA. Okay, again, uh, so this carry in underscore FA is acting as an input for this B. Again, this one is given. Okay, this is sum underscore FA. So this output is sum underscore FA. Okay, and next this C is there now. This C I am taking out, and this is I am giving as a input to
or
carry
get.
or gate, and here I am getting carry underscore F, carry underscore F. Okay, so total this one is my full adder. No,
Yes, sir.
this one is my full adder. Okay, intermediate variables you consider as net data type. This is nothing but W1, and next this net you consider as this is net. Okay, net this is W2, and this one is W3. Okay, first what you need to do, tell me.
We need to write code for off
Half
adder.
adder, yeah, you need to write the code for half adder. Okay, so I'm writing the code for half adder. Module half underscore adder, input I need to declare input
A B
A, B, and output
some can
S comma C, S comma C, and I'm using the continuous assignment data flow modeling only. Assign assign S equal to what? A XR
A
C, and assign
array equal.
carry equal to A and B, carry equal to A and B, and end module. Okay. So first I wrote the code for half adder circuit. Okay. After that,
Okay.
after that, what I need to do?
Have to instantiate the second like next.
Yeah. So first I need to write the code for full adder circuit module. My module name is full adder. Input input A underscore FA, comma B underscore FA, comma C in underscore FA. Okay. Comma output output sum underscore FA, comma what is the output? Carry underscore FA.
E C F A.
Carry underscore FA. Okay. And I need to declare the internal nets. No,
Hmm.
this is internal nets. W1 is nothing but one net. This W3 is also one net. Okay. So I need to declare with wire data type. Wire W1, W2, W3.
W3.
Okay. So next I need to instantiate. How I am instantiating? My design name. What is my design name? Half
Half
adder.
adder.
Half adder. And instance name HA1. Okay. Connection by name is what? Dot A
Dot
with
A of
A under
AFA.
AFA dot B
Dot B of BFA.
B underscore FA, and dot
Dot S
dot S. What you will get?
of
W1. No?
W1
W1 W1 dot next
C
C W2 dot C W2. Okay, W2. This is nothing but correction by name. Okay, and similarly for second adder also I need to write half underscore adder HA2. So for this HA2, what is the input?
Y W1
Dot A dot A
W1
W1. It is coming from output. Okay, W1 comma dot B design input. Okay, dot B
C in FA
Cin underscore fa Cin underscore fa and dot s
S
dot s some underscore fa no
underscore FA
some underscore fa and comma dot c w3 no
W3
w3 dot c w3. Okay, and next assign. I'm using as a continuous assignment statement assign carry underscore fa, that is equal to what? W2
or
or
C
operation with W3. W2 or operation of W3. W2 or operation of W3 and end module. Did you understood how I'm writing? How I'm using the connection by name?
Yes, sir. So, but you didn't declare here sum full order.
Hmm.
You didn't declare the sum of full order assign
Some underscore.
FA. Like, uh, what is the equation to sum?
Some underscore fa within the outputs I declared, no?
Hmm. But
Within
in the code you declared only this carry a full adder. But where is sum FA?
this one.
Hmm.
This one I declared, no? Output. Output.
You you
Input.
mm,
This is input. Okay. This is input and this is output for the full ladder. So within the
yes,
module itself I declared, no? Here I
you
declared.
declared correct.
Uh,
But in the code you written only assign carry FA. But where is sum FM?
one second. One second. S dot sum underscore fa c dot w3 w2. I'm declared in the output, no? But I'm not
You,
understanding your doubt.
you declared in the output, that is correct, sir. But you
Uh,
have again you written like here in the last assign carry FA equal to W2 or W3, right?
yes, yeah.
But you didn't written like for the sum FA.
Why? Because carry underscore fa equal to what? This
This
is with
is
or gate,
yeah,
no?
or game.
So I'm using this. This is nothing but assign carry underscore fa equal to what? W3 W2 or operation with the W3.
W3.
Some directly by instantiation you are getting.
Okay,
Okay.
sum directly. That's why you
Uh,
didn't.
yeah, we are getting, but so carry, if you see, carry means through OR gate only you are getting, no?
Yes, sir. To or get. Yeah.
So that's why um, I used carry underscore.
Got it, sir.
Got it? Yeah. Yeah. Okay. Yeah.